beam was going to come on in like half an hour. Hello, welcome to Lancaster Hi-Fi. Today, I want to talk about building technical skills through problem solving. And I want to tell you the story of one of my proudest achievements. To me, electronics is kind of like computer programming. Programming, like electronics, is hard. It's not that hard, but there's a steep learning curve that just has to be climbed in order to gain real skills. Book learning is necessary, but not sufficient in building skills. Practice at solving problems is also necessary, and the best problems are real rather than contrived. That's why taking classes doesn't always work. Problem solving is generally difficult, and contrived problems aren't motivating enough. And real problems often have the advantage of existing solutions to build on. And no one's hiding those solutions so you can learn for yourself. I'll give you an example from my learning programming. I wrote a few programs in BASIC for my linear algebra class in college. It was aggravating as hell, partly because it didn't matter to me, not enough to make me want to do something that difficult. In my first job out of college, I was a lab assistant at Fermilab, the big DOE particle accelerator lab outside of Chicago. I wasn't on one of the glamorous collider experiments searching for the top quark. I was on a fixed target experiment, one of many at the ends of beam lines peeled off from the main accelerator loop. Basically, I was stuck out on a big concrete bunker next to a cornfield. For real. When the beam wasn't running, that is most of the time, there wasn't always much for me to do. I just helped babysit the detectors and their associated systems. There were these blaze orange rack-mounted high-voltage power supplies, and just about every detector had racks full of them. They would often fail, and we'd have to swap them out for good ones. They had to be coaxed into providing the necessary, say, 10,000 volts for the detectors. You had to start at zero and turn them up slowly, and you often had to back off the voltage and ramp them up again when they didn't initially do what they were told. And all that coaxing and slow ramping had to be automated. There were simply too many of them to be twiddling knobs. Within the large group of people composing the E665 collaboration were small groups of people associated with various institutions. Each small group within the larger experiment was in charge of one of the set of detectors. I was with the Harvard group, and we were responsible for the electromagnetic calorimeter. Don't worry, I don't know exactly what it was for. I just know it had a bunch of rectangular cells, like yay big, each full of flammable gas and laced with high voltage wires. Right? Each cell had its own power supply. There was a Fortran program that, when compiled and executed, turned on all those power supplies. But it didn't always work, and we really needed it to always work. If it didn't work, the whole experiment might waste beam time, which was valuable. Like, it cost a lot, and it was irreplaceable. With time on my hands, I took on the problem of fixing the program so that it would always work. That meant making it more coaxy where needed and dealing with previously unforeseen failure modes. I read some of a Fortran manual, but talk about boring. I'm not sure I made it past Hello World, but I really wanted those dang power supplies to turn on smoothly. I mean, that experiment was full of physics professors, postdocs, and grad students. All they wanted to do was analyze data, but that was way over my head. I couldn't contribute to that. But none of those geeks wanted to deal with hardware any more than absolutely necessary. So hardware, or more precisely, the software used to turn on and monitor hardware, was where I could actually contribute something meaningful. I could decrease the amount of wasted beam time and actually give the scientists more data. So that's how I learned to write Fortran code. I started with the existing code. I went through it with a fine-toothed comb and figured out exactly what the code did. I looked for things that needed improvement and figured out how to make the improvements. I looked for places where the logic might hit a dead end without successfully ramping the voltage all the way up. The old code typically resulted in the different detector cells having different voltages. That meant that given the same stimulus in the form of some subatomic particle whizzing through a cell, different cells would have different responses. Some cells might fire and others might not. I was determined to get every cell sitting right at 10,000 volts or whatever, not some at 10,000 and others at 7. And I got that program to work. It came down to the wire, though. The beam was scheduled to come on, and I was still debugging that program. My immediate supervisor, a postdoc named Guang Fang, was standing behind me, or sometimes pacing and reminding me that the beam was going to come on in like half an hour, and asking whether our detector would be on in time. I answered yes, and I did it, with literally minutes to spare. No high five, no attaboy, nothing. Just the satisfaction in getting it done. What was the trick? The trick was knowing that it wasn't that hard and having the guts to try. Not being afraid of making it worse. I knew that worst case, we still had the old lousy version of the program and we could use it if we needed to. But while I still had minutes on the clock, I didn't give up. Solving electronics problems requires different skills, but the trick is the same. As long as I have the necessary tools and parts, none of the problems I've faced has been unsolvable. Do I sometimes put a problem back on the shelf for a while? Sure. And I make mistakes, usually stupid ones. Sometimes I have to hit the books or the internet and read a bunch of stuff before I find some useful tidbit of knowledge. I bitch and moan and have friends online remind me to do the most basic things. I have a lot to learn. Mostly, though, I just need to be too stubborn to quit. By the way, I actually made it onto the author list of one of the papers that came out of that experiment, E665. Not that I could tell you what it's about. I'm one of the 93 co-authors. Hey, I picked up some new old stuff on my recent trip back to Arkansas. Check it out. I got a couple of things from an old family friend, Clark Calvert. This is a tube tester. And he gave it to me for like $40 and made sure it worked. And here's the other thing that I got from Clark. It's a Sansui 1000 stereo receiver. They later released the 1000A, and I think also the 1000X. But the 1000A was more of a fundamental redesign. This one is more like the SM80, which was an integrated amplifier, I believe. The 1000A and later had 7591 power output tubes. This one has, friggin' hell, what are these? 25E5 tubes. That is, they have 25 volt filament voltages. The dial face, the front plate, etc. are in really good cosmetic condition. It doesn't have a case, so I'm going to have to get a case made for it. And from my friend Bob, the one that I made a DGSE1 for, I got this Magnavox Amp 175 chassis. I also took him a CD player, a Rotel CD, RCD 855 that I had restored and modded for him. And I also got to troubleshoot his system. He'd gotten some weird noises coming up, and we figured out that essentially the power amp was sitting too close to a switching mode power supply, and it was causing some nasty noise to come out of one channel. But that was cool because he found out he doesn't need new crossovers in his La Scalas, and that there was nothing wrong with the amp, which I built. So that was a relief for me. I'm sure the not needing new crossovers was a big relief for him because those are pretty pricey. And finally, completely unrelated to hi-fi, of course, is this map of the plantations on the Mississippi River. This hung in my grandparents' entryway in Oklahoma City. The map itself is not rare. You can buy reproductions of this map, but this one, of course, has quite a patina, including sort of being scorched in a house fire. It has a beautiful frame, and perhaps even more importantly, it has notes on the back and even corrections on the front by my grandfather explaining some of the history and his connection to some of the history on this map. I also study rivers for my day job, and so this map of the Mississippi strikes that chord with me as well. That's all for now. I hope you enjoyed the video or found it useful. If you did, please subscribe if you haven't already. Hit the bell for notifications, hit the like button, and leave a comment. Have a great day.